Okay, so today we're going to talk about turning verbal expressions into inequalities. And this is AA6 for the Integrated Algebra Learning Standards for New York State. Analyze and solve verbal problems whose solution requires solving a linear equation in one variable or a linear inequality in one variable. So clearly we're focusing on the last part of that learning standard. Okay, so right now you want to pause the video and write down all of these things. These are words that mean these specific inequalities. So, for instance, x is greater than 12. That can be said as a number is more than 12, a number exceeds 12, a number is greater than 12, and a number is over 12. For greater than or equal to, a number is at least 12. So it's either 12 or it's larger than 12. A number has a minimum value of 12, all right, so that also says that you can include 12 there, but every number greater than 12 is also included. A number is no less than 12. A number is not under 12. All of these phrases mean less than or mean greater than or equal to. Less than, x is less than 12 would be a number is less than 12 and a number is under 12. Whereas less than or equal to is a number is at most 12, a number has a maximum value of 12, a number is not greater than 12, a number does not exceed 12, a number is not more than 12. Okay, so take a moment and write these down in your notes. Okay, so this is our first translation. All right, our procedure is going to be similar to what we did with the equations. We're going to try to find our x first. We're going to write everything in terms of x. Then we're going to solve the inequality, or write the inequality down, solve the inequality, and check your solution, and graph the solution and write in interval notation. So Serafina has $53.50 in her pocket and wants to buy shirts that are priced at $14.95 each. How many shirts can she buy? So if x is equal to the number of shirts, okay, I found my x, okay, and every shirt is $14.95 each. To get the value would be $14.95 times x, okay, and she only has $53.50. So the price of the shirts have to be less than or equal to $53.50. Okay, they can be equal to the amount that she has in her pocket because she can spend all of her money, but they definitely have to be at least less than that. Okay, or another way of saying it is they can be no more than $53.50. Okay, so I found my x. I wrote things in terms of x. I wrote the inequality, and now I'm going to solve it. So if I divide each side by $14.95, okay, x is less than or equal to. So if I wanted to actually do this division, I could ask myself, how many times does $14.95 go into 53? So let me estimate here. $14.95 is almost 15, and 15 times 3 is 45, and 15 times 4 is 60, so it has to be between 3 and 4. So let's see, and we want a whole amount because since x is the number of shirts, you can't get a partial amount of shirts. So let's see. Okay, so the actual answer to this inequality is, I just pulled my calculator out and did it. It's 15, is x is less than or equal to, and I'm going to round to the nearest hundredth, so I'd get 3.58. Okay, but we know that x has to be the number of shirts, and that can't be. That has to be a whole number, right? The domain, the answer here is x is less than or equal to 3.58, and if I were to graph the solution, here would be 3 and 2, so x has to be less than or equal to somewhere in between, so between 3 and 4. Okay, so I could put, but x has to be the number of shirts, so x has to be actually less than or equal to 3. Okay, interpreting it back into the word problem, x can't be equal to 3.58 because you can't buy 3.58 shirts. Alright, so the number of shirts have to be less than or equal to 3. So let's graph that solution. closed circle at 3, and shading down in between. Then actually there's an implied lower bound to this, okay, which is 0. So x has to be between 0 and 3, and it has to be integer values. So let's write that down. 3, 0. Okay, and it can you can buy 0 shirts, so you can include that value of 0, and you can buy 3 shirts, so you can include that value of 3. So there's, I graph my inequality, and interval notation means I can go from 0 to 3. Okay. So actually I should have written a compound inequality here. It's implied. So x is less than or equal to 3 and greater than or equal to 0. Okay. What is the domain for this problem? So the domain for this problem is actually what interval notation is. So the domain for this problem is 0 to 3, and it has to be a whole number. So any whole number between 0 and 3 is the domain. And our second and last example, the length of a rectangle is 5 centimeters more than its width. The perimeter of the rectangle is at least 66 centimeters. Find the minimum measurements of the length and the width. So first I have to find my x, okay, and I do that by looking at the last, usually it's the last word in the sentence here. So if x is equal to width here, then the length would be 5 centimeters more than the width. So it'd be x plus 5. Okay, and the perimeter we know is 2 length plus 2 width. So putting those numbers in, actually putting all the information in, we have the perimeter is at least 66. So if the perimeter is here, then the lowest that number can be is 66. So 66 is less than or equal to what the perimeter is. So 2 times, now this expression is standing in for length, plus 2 times n. X is the width. So let's go ahead and solve this. This would distribute in, so it's 2x plus 10 plus 2x. So 2x and 2x is 4x. Okay, subtract 10 from both sides. We have, I'm going to bring it up here, we have 56 is less than or equal to 4x divided by 4 divided by 4. Since I'm dividing by a positive number, I don't have to switch the inequality. I don't have to flip it around. Alright, 56, 28, so that x is greater than or equal to, or 14 is less than or equal to x. So the width has to be, the minimum value of the width is 14 centimeters. That's for the width. And the minimum value for the length is 5 more than that, so 19 centimeters, okay? That's the minimum for the width and the minimum for the length. Okay, and that was our last example here. So make sure to look for clues in the word problem. At least was identified as meaning that the lowest number it could be is 66. So it's not a strict inequality. It can be 66, but that is the lowest number it can be. All right?